Welcome to Algebra 2. Today we are going to be learning about how we use exponential and logarithm functions. So the first way how we use these is if we have something called exponential decay. There are two separate formulas for exponential decay. The first formula is y equals a times 1 minus r to the t. A stands for your initial amount. R stands for the percent of decrease, and this is always going to be expressed as a decimal. And t is the time in years. Our second formula is y equals a e to the negative kt. A is still the initial amount, t is still the time, and k is a constant. This constant depends on what type of material we are using. This is always going to be the formula that's used for science. So things like carbon dating, those type of things, this is the type of formula that gets used. So we're going to do some examples with this. So first, for our first example, we have a cup of coffee contains 130 milligrams of caffeine. If caffeine is eliminated from the body at a rate of 11% per hour, how long will it take for half the caffeine to be eliminated from a person's body? So we need to decide which of these two formulas make sense. Since we have a rate of 11% per hour, we're going to use our formula that has a rate of a percent in there. So we're going to use y equals a times 1 minus r to the t. Y was not stated up here, but y is always the ending amount. So we know our starting amount is 130, so that would be our a. 1 minus, we know our rate is 11%, so 0.11. And we want to know for how long for half the caffeine to be eliminated. Well, half of 130 is 65, so that would be 65. So to solve this, we're going to try to get our value raised to the t power alone. So we're going to divide both sides by 130. Well, 65 divided by 130 is 1 half. 1 minus 0.11 is 0.89 to the t. And now this is a matter of just solving using either logarithms or natural logarithms. It doesn't matter which one you use. So I'll take the natural logarithm of each side. And now I can use my properties of logs, because here we have an exponent, so that t can be multiplied out in front. So this would become the natural log of 1 half is equal to t times the natural log of 0.89. And then to get the t alone, I would just have to divide both sides by the natural log of 0.89. So natural log of 1 half divided by the natural log of 0.89, that gives us 5.95. So we would answer this as about 6 hours. So it would take about 6 hours for that caffeine to be eliminated from someone's body. So now we're going to do the same, using the same information, but now for how long would it take for 90% of the caffeine to be eliminated. Well, if 90% of the caffeine is eliminated, that means only 10% is remaining. So this would say, so instead of 65 being our remaining, 10% of 130 is 13. So this would say 13 equals 130 times 1 minus 0.11 to the t. And once again, we'll solve it using the same exact steps. So we'll divide both sides by 130. Then we have 1/10 is equal to 0.89 to the t. Solving using logarithms or natural logs, we would then have the natural log of 1/10 is equal to the natural log of 0.89 to the t. Using our properties, that exponent can be dropped in front. So the natural log of 1/10 is equal to t times the natural log of 0.89. And then to get the t alone, we'll divide both sides by the natural log of 0.89. So the natural log of 1/10 divided by the natural log of 0.89, we get 19.756, or we could say this is about 19 3/4 hours. Alright, so that's how we use it. We're going to look at a few more examples with this. This next example asks us to find what the K value is for sodium-22. So it tells us the half-life of sodium-22 is 2.6 years. We want to know what the K value is. So clearly we're going to be using the formula y equals a e to the negative kt. Half-life. Some of you may not have encountered this term before. Half-life means the amount of time it takes for half of the sodium-22 to disappear. So what that means is our ending amount would be half of our initial amount, which would be 1. And then we would have e to the negative k times our time is 2.6. Well, dividing both sides by 1 isn't going to change anything, so this would be 1/2 equals e to the negative 2.6k. So then from here, we could certainly take the natural log of both sides, or we could just write this in terms of natural logs. I'll show you both ways. So this would be the natural log of 1/2 equals the natural log of e to the negative 2.6k. That negative 2.6k, using our properties, goes out in front. So the natural log of 1/2 equals negative 2.6k, and the natural log of e is just equal to 1, because it's like log base e of e, so that would just equal 1. So times 1, we don't need to really write anything at the end of that. So the other way is, if you would have taken a look at this equation, you would have known that you would have taken the natural log of 1/2 is equal to negative 2.6k by converting this over to natural logarithms. Either way, you get the same result. So now we'll divide both sides by a negative 2.6. So we take natural log of 1/2 and we divide it by negative 2.6. We end up getting a k value of 0.266595. And for k values, you write down as many values make sense. So after this 595, there was a 0 for the next place, so that would be a logical place to stop. So now part 2 of this question is we have a geologist examining a meteorite, estimates that it only contains about 10% as much sodium-22 as it would have contained when it reached the Earth's surface. How long ago did the meteorite reach the surface of the Earth? Well, we now have the K value for sodium-22. We have the percent that it contained at the end, and so we can fill in what we know. So the ending amount is 10% of its original amount, which would be 1. E to the negative 0.266595 times our time. And now we solve this. So dividing both sides by 1 won't change anything. So let's take the natural log of both sides. Natural log of 0.10 is equal to the natural log of e to the negative 0.266595t. Then once again, this exponent gets multiplied out in front. So the natural log of 0.10 is equal to negative 0.266595t times the natural log of e, which we know is 1. So we don't need to write that there anymore. To get t alone, we'll divide by the negative 0.266595. And when we do that, when we take the natural log of 0.10 divided by our negative 0.266595, we get a time of 8.6 years. So that would be our solution. We're now going to look at. Notice that in your note packet there is another example about carbon dating, carbon-14. That example is done on another lesson. So if you need more help with it, go to the next lesson. So now exponential growth. Pretty much the same formulas, but the difference here is we have a 1 plus r and a positive k because we are now growing instead of decaying. But our A, R, T, K, those are all standing for the same thing. So we're just going to jump in and try this last example here. The population of a city of 1 million is increasing at a rate of 3% per year. If the population continues to grow at this rate, in how many years will the population have doubled? Here's our rate, so we are going to be using our 1 with our rate percent. So we'll be using y equals a times 1 plus r to the t. So we know the initial amount is 1 million, and we want to know in how many years it's going to double, so the ending amount would be 2 million. There's no sense in writing all the zeros for after 1 million and 2 million. We can just say our initial amount is 1 and our ending amount is 2 because it was doubled. And then 1 plus the rate, so 0.03 to the t. Dividing both sides by 1 doesn't change the 2, so that we now have 2 equals 1.03 to the t. We can now take the natural log of both sides, so the natural log of 2 is equal to the natural log of 1.03 to the t. Using the properties, the t can be multiplied out in front, so the natural log of 2 is equal to t times the natural log of 1.03. And we can divide both sides by the natural log of 1.03 to get our time alone. And time then gives us about 23.5 years. Alright, so that is our exponential growth. And we just did exponential decay. Like I said, there are some more examples in the next video if you need some more help with this.